Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with Fourier series problem, the interval minus pi to pi. See the problem, find the Fourier series for the function f of x equal to modulus of x, the range minus pi less than x less than pi. Hence deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on equal to pi square by 8. So generally Fourier series, when the interval minus pi to pi, then the Fourier series expansion is nothing but f of x a naught by 2 plus n from 1 to infinity a n cos nx plus summation 1 to infinity b n sin nx. Now the Euler formula, the coefficient value to calculate a naught 1 by pi minus pi to pi f of x dx, and then a n 1 by pi minus pi to pi f of x cos nx into dx, then b n 1 by pi minus pi to pi f of x sin nx dx. Now this is a general formulas for minus pi to pi, but suppose we can use this formula very lengthy procedure. What is a lengthy procedure? Suppose if you want to calculate a naught, the a naught is nothing but minus pi to plus pi. So the 0, okay, when it's a modulus of x, negative and positive. Therefore the f of x when is negative minus x, the f of x when is positive x. So we should split with this interval minus pi to 0 f of x dx plus 0 to pi f of x dx. Then substitute f of x value when the negative range and when the positive range, integrate, substitute upper limit, lower limit. Similar procedure for finding this a n, b n, so it will be lengthy procedure. Then how to solve this? Any short form? Yes, the short form is possible when we should apply with odd function, even function. So the odd function, even function is nothing but when we can apply odd function, even function when the f of x, the range, right? So odd function, even function, odd function or even function when minus infinity to plus infinity, minus pi to plus pi, minus L to plus L, minus 1 to 1, minus 2 to 2 and so on. So when it's a full range, then only we can apply with the odd function or even function. So odd function is nothing but f of x replace to x2 minus x, then minus f of x, it's a odd function. Then even function f of x when replace minus x, again f of x, it's a even function. So when the function f of x given, to test the given function, odd function or even function. Here f of x given modulus of x, when I should replace minus x, it's a modulus of. Therefore minus of x modulus is nothing but modulus of x, it's a positive x. Therefore f of x, when I replace f of minus x, again it's coming f of x. Therefore the f of x equal to modulus x is an even function. So even function, then what is the formula? F of x equal to a naught by 2 plus summation from 1 to infinity a n cos nx, because of when the even function a naught a n formula value possible, b n 0, when even function b n 0. So therefore now a naught 2 by pi 0 to pi f of x dx, and then a n 2 by pi 0 to pi f of x cos nx dx. So this is a formula when we should apply with even function. Now to find a naught a n, so b n 0 because it's a even function. Now a naught 2 by pi 0 to pi f of x value x dx, because positive side, so when it's a positive side it's a modulus of x, when it's positive then 2 by pi 0 to pi x dx, positive side positive x. So x integration x square by 2 0 to pi. So when I substitute upper limit and the lower limit, pi square by 2 minus 0. So therefore now cancel this pi 2 2. So now the value a naught pi, and then an. So an equal to 2 by pi 0 to pi f of x cos nx dx. F of x value modulus of x cos nx dx. Now when the range positive side, therefore x cos nx dx. So what is the formula for Bernoulli function when uv dx equal to u v1 minus u dash v2 plus u double dash v3 and so on. So this is a Bernoulli form. So this is a u and this is a v. Now the formula is nothing but 2 by pi, so u v1, so u x v1 cos nx integration. So what is the integration? Cos nx sin nx by n, then minus, this is a differentiation, u dash mean x differentiation 1, v2 this term integration minus cos nx by n square. So other term 0. Now stop the process, 0 to pi. So substitute upper limit and then lower limit, 2 by pi into sin n pi by n, then minus plus cos n pi by n square, this is the upper limit, minus of lower limit 0 into any term 0 plus cos 0 by n square, and sin n pi 0 cos n pi minus 1 power n cos 0 1. So therefore when I substitute pi, the whole term 0, and then cos n pi minus 1 power n by n square, then minus 1 by n square. Therefore an equal to 2 by pi minus 1 power n minus 1 by n square. Now substitute a naught an in the Fourier series expansion, a naught pi by 2 plus n from 1 to infinity an 2 by pi minus 1 power n minus 1 by n square into cos nx. So this is a Fourier series expansion. Suppose the question is only find the Fourier series, you stop up to this, but hence deduce that. So when the points to calculate, when hence deduce that, then f of x is nothing but put x 0. So therefore the f of 0 equal to pi by 2 plus 2 by pi n from 1 to infinity minus 1 power n minus 1 by n square into cos nx. So f of 0 means f of x modulus of x, f of 0 0. Therefore 0 equal to pi by 2 plus 2 by pi. When I substitute n equal to 1, so when 1 minus 2 by 1 square and cos x, I think cos 0, the whole term 1. So now this term is 1. Therefore this is a next I will continue. This is a summation n from 1 to infinity minus 1 power n minus 1 by n square. Now the pi by 2, this term when I shifted left hand side minus pi by 2, then 2 by pi. When I substitute n 1, So minus 1, then minus 1 by 1 square. Similarly 2, 3, 4 and so on. So therefore this is a minus 2 by 1 square plus minus, when I substitute 2, 2 means the whole term 0, then minus 2 by 3 square, next term 0, minus 2 by 5 square, and then next term 0. So therefore here when I shifted this 2 pi in the left hand side, minus pi by 2 into pi by 2, then when I am taking minus 2 common, 1 by 1 square, 1 by 3 square, 1 by 5 square and so on. So this is a minus cancel, and then pi square by 4 equal to 2, and then this 2 when shifted to left hand side, pi square by 8, 1 by 1 square, 1 by 3 square, 1 by 5 square and so on. So this is the final answer. Thank you.